Okay, thank you very much for the introduction there. So my name's Giles Martin and my colleague Michael. Obviously here to talk about the historic maps and some services that we use those in ourselves. So by way of introduction, just a quick overview of Landmark and where we sit in the use of the historic maps. So Landmark Information Group is very much a property-led services business. So we've probably touched on the process of anybody buying a house in England, Scotland and Wales. So through the various services we provide, all based off the knowledge of geospatial data, and with our environmental services and consultancy very much so using the historic maps that we're presenting about today. So we use the data as well as supplying it for the Digimap service. We are a partner with the Ordnance Survey, in fact their largest partner. And the division we work in is in Landmark Solutions, where we provide a lot of data, intelligence and services based around, I won't talk through all of these, but these certainly the areas you can see on the screen there. So it's all around digital mapping, digital data turned into services based on location. Part of that includes using the historic data and providing historic map services for the services such as local authorities using it for a lot of their environmental planning constraints work. So just while we're all here, the historic maps. So the history of the historic maps as a digitized product is it was originally done through a joint venture with the Ordnance Survey, where Landmark scanned all of the archives of the paper maps. So we sourced them from the different repositories around the UK and digitized those into the maps you see today. And we put the georeferencing service using a process created by an academic called Brian Adams to overlay the grids and put them into projections, matching all the different, and we'll go into projections in a minute. But all the projections, so you can have a seamless layers of digital data when you load the maps either into the WMS mapping service, as you can see here, that you access, or as you take data as a download. And that was covering the pre-World War II Cassini County data, and then post-World War II when he instigated, or the Ordnance Survey instigated, the national grid that we all know and recognise now. So, as I mentioned, we publish the WMS service that everybody is using through Digimap services, and that was done through matching all of the scanned paper maps, geo-referencing those against the OS historical archives. That created what is now over 1 million map images at varying scales, both in the county and national grid series, as you can see here. So we amalgamated the different scales used at different points in time to create layers of the data so that you can see all of the available maps, but it's not too confusing to understand, I think, is the simple way of putting that. And I'll pass on to Michael now, just to take you through the detail of how the mapping is managed and created.
Thanks, Giles. Okay, hopefully everybody can hear me okay. The historic maps were quite a complex set of maps that were in the transverse Mercator projection. And each particular county had its own central meridian and an origin based on different parts of the country. And so they share overlapping areas, and they share some parameters around the edges of the maps. And each one of them is surveyed, a sheet at a time. So, and then of course engraved onto copper plates for printing and what have you. But the whole process was, if you come back a bit, one more click, Giles, on this one, I think should show what so in the case of how we do it, because each sheet was surveyed and projected separately, you end up with a situation, if you click one more, the end result is that you will have a situation of different, because of each central meridian being different for each sheet. then you end up having a situation where overlaps occur, and too much overlaps will obviously involve not being able to see the data correctly. Therefore, we had to kind of go with a way of managing these projections so that we can handle the overlaps and the different types of projections between the Cassini world and the British National Grid. So, yeah. Next one, Giles, if you could click on.
Yeah.
So the whole process of how these maps were scanned and put together to a mapping service that would handle all of them in whatever projection they were in is called a mosaicing technology and imagery. And we used the image technologies around the Esri platform for this, where we employed the mosaicing technology, where you're able to do like a big bucket. You can just throw images in there as long as they have appropriate world files. Then it would work out the particulars and the neighbors and the projections it would project things on the fly, and it would have a lot of different properties that you can manage. So you can have seamless imagery. You can also have it driven by an attribute. And in this case, the attributes we used were county ID and the actual year of that particular historic map. So it allows you to do things like building pyramids. It allows you to do auto rectification, enhance the images, color corrections, and all sorts. I mean, probably lots of you out there know about these image processing systems out there now. But the beauty of this is that you can have referenced raster catalogs where the files are stored in a large storage area in a particular folder, and all you're doing is actually referencing them through and doing all of the temporal management, projection management, and corrective situations that you wanted with those together as one, but always only reference. You don't have like a huge database that is so hard and cumbersome to move. What you have is what they call GIS or file geodatabases that are pointing to these referenced TIFFs to make the actual mosaics happen. So it makes it technologically feasible to manage a lot of it all at once. If you can go ahead, Giles, next one.
Yeah.
So this is just a complicated little diagram that I threw up there just to put fear in people. Not really. It's really just the rules. Rules have to be carefully applied when you're developing mosaicing rules, especially for these types of maps where they overlap and their temporal time of years are different. And so what we've got is kind of using the mosaicing functions of order, so that there will be like a Z order. So if you think about XY coordinate, then you have a Z order for like an altitude. We are using the year as the altitude, so that it does like a peel off of layers as you go further into earlier years. So, the 1980 would be flipped over and removed so you can see 1970 and so forth. And that Z order is handled by the date fields that are in the mosaic indexing files. So this is just a quick view of how you can handle multiple imagery and multiple inputs and scales and times within one image data set. So next one, Giles. These are the map scales and the number of maps that were involved in each one of these. So there's, town plans, and then we have urban, and then we have rural. So they all had a range of time from 2 years and what scale they were produced at and how many TIFFs were involved in that production process. So we're able to compile all that and process it into a very large set of 2 main services. So if we could click on the next one, Giles. I think that's, yeah. So that's sort of the distribution of the spatial part of where these town plans are, where the urban ones are. So obviously we have a lot of rural. We have a considerable amount of urban and some town plans in certain red specks throughout the country. So, okay, here is the build process where we basically, if you click the next one, yeah, it gives you an idea of about we had 1 terabyte of these TIFFs. As you can see there, you can read for yourselves, quite a few files, lots of directories and folders to separate them out into different timeframes and counties. The originals that were stored uncompressed would have been a lot larger than 1 terabyte. It would have been quite a bit bigger to do that. And in the processing of the original TIFFs, before we could even make the geodatabase raster catalogs, so that we can then go ahead and make the mosaics, we had to do a lot of processing of the coordinate system headers in the TIFFs. So because they've been around for quite a while and used by different people with different technologies, some people in MapInfo, some people in Esri World, some people in other places of using imagery software, have had the issue where the headers of the TIFFs, some had them in embedded, some had them as external world files, and actually some had them in a different format inside the header. So we had to go through all of them and fix the actual headers so that it matched where we wanted to end up, which was a file geodatabase, a geodatabase in Esri format for Mosaic. So we had to do quite a bit of work in fixing the headers, and then building the catalogs, which, if the catalogs were about, took about 3 or 4 days, 72 hours to process a catalog, 442 catalogs. If you think about that is almost, it's a long time. And I remember it being a very long time, close to almost 1.5 years of processing time, but over elapsed time. It wasn't really exactly like that, but it months and months and months of labor in the back of a server, just sitting there crunching through and fixing and mosaicing all these catalogs so that we could then build the mosaics from the catalogs. Go ahead, Giles. So really, there are 2 main services that we built out of these historic maps. So the first option is that everything is in there at all scales, but it's time sequenced, and time sequences being the year. And the other secondary service that we have for that is that they are actually first split into the 3 broad scales of the town plans, urban and rural, and then after that they are sequenced with the year. So two different types of map services for 2 different reasons of how people want to visualize it. And part of that is the fact that in the mosaicing world, in the rules base, because we have an index that pretty much knows the boundary of each TIFF, in that particular boundary polygon layer, we're able to store the attributes and use definition queries so that we can query different times and different years and different county IDs depending on what type of things that people wanted to see. But in general, the consensus was we'd have 2 map services that would do this in certain ways, that depending on people's needs. Go ahead. And in one of the services, the way we handled overlapping was basically on the basis of either time, and if there was a tie, time wins. So that if you're showing sequence 1, you wanted to make sure that you saw the latest, you would use the sequence 1 map series. And if you wanted to not necessarily worry about that, but you're trying to detect the overlaps between different counties, you'd use sequence 2, which was sorted by the county ID, so that you could isolate a specific county. So if you could just go to the next slide, I think it tries to make sense out of that. So it's a very complicated little diagram to understand in that sense, of what would show up first, whether you're showing the county priority or you're showing an actual time priority on each one of the sequences. This was all designed by, Dr. Bill Honey, who used to be with Landmark, has now moved on. But he spent quite a bit of time building this series of mosaics and sequences so that it is presented as easily as we can, given all the overlap situations and timings and projections as well. So quite a complicated little process. Carry on. Okay, so another aspect we added to the service is the ability to add masks to that. So there's certain folks who only want to see a certain part of the country, like Scotland only, or a specific county only, and so on. So we would then have other polygons that we could put into the system and publish it such that a custom published service for that specific customer would allow them to see their data in their area only and nothing outside of that. So that was, it just depended how much licensing there was involved in the process of deciding how much to use in the service. So that's, masking was just used to control that. Consuming services, it's basically we were able to provide a WMS URL that would give you an ability to put it into your GIS desktop, such as Esri ArcGIS Pro, ArcMap, including QGIS, MapInfo. And the other one was then, without any particulars to a GIS desktop, you could consume the service in your web browser. So whether you're in Safari, Chrome, or Edge, you get a URL that would eventually kick up this application you see on the right side. That then gives you more of a time slider built in, and you're driving around and looking at the maps that are overall available to the whole country in this case. So next one, Giles. By the way, jump in, Giles, if I've skipped anything, missed anything.
No, I think you've covered the definite detail of how the maps are built.
Yeah. And so what we do to secure these things, and this is not just an open service, it is secure. We use token authentication for those that need to use it in their desktop world. So we give you a URL that is kind of anonymized. The web browser application is then based on a specific username and password that you're assigned in order to consume that in the web browser. What's next, Charles? There we go.
What's next? I was going to say on the web browser there, Michael, as well. It does make the data very easy to consume and use. So it allows people who aren't skilled or have the ability to access the GIS software or overlay or the need to overlay it with other data. It's a very quick and easy way to view the historic maps and see the change there.
Very good point. Thank you.
We've just got some examples now, don't we?
Yeah. You go for it. It's all you from here.
Okay. This was just some examples here of just how the historic maps, you can see the change over time as using this site. It's in the centre of Manchester. So this was the the maps that existed in the county series in 1851. Then moving on to, this is still county series, but in 1891. I can't remember the scale here. I think this was at 1 to 250.
250.
Yeah. If you move through time, you can see as those barracks have then changed and new streets have become, obviously in Manchester, we picked Coronation Street as an example. You can see the recreation ground and the change that's happened there in the 50s. And then another ordnance survey map in 1994, which interestingly is referenced as having the same scale, but is a different mapping product to the previous one. So you're not seeing all the buildings in the same detail as the previous one. So that's like if you're looking at current mapping today, that's essentially your comparison between your master map and your vector map local products, or your NGD product as it would be at the moment. Okay, and then we've just got a few case studies of just where we've used historic maps in services provided to our customers and projects we've run. So one of our clients are the national highways, where they have a very large data store of information for enabling them when they're planning the maintenance and development of their road network. And they have a historic maps archive that we supply as a service into that for all of the major road networks they manage in the UK, giving them access to, well, as it says here, over 32,000 Ordnance Survey maps. Because the big factor when you're developing new roads or maintaining them is the geology or the change around them and the impact that has. So in addition to the historic maps, they also overlay data from the British Geological Society, plus a lot of their own information as well. And it all gives them that insight they use. And then they also use the WMS service for the wider organization, so they have a quick and easy access to view the time slider side of the data, just to see where the road network previously would have been, or what would have been there previously, so they can understand any factors that would have an impact there. You may be familiar with this website that we run. Stepping away from historic maps for a moment, this doesn't include the historic map data, but it does include over 380 different geospatial data sets. And it is essentially a mapping platform that enables users to access over 4 million maps a month for natural England. And I'm going to put you on the spot. I was going to say I couldn't remember the name, the abbreviation of Magic, and that's why I typed it into the top of the slide there. The multi-agency geographic information for the countryside. So it's a geological, administrative, mapping, marine, any data there for that one, and that's a extremely well-used service, all running off the same platform within Landmark as the historic map archive. So we often say to people, if you want to see the level of service delivered outside of the historic maps prior to trialing it, you can see that within Magic. And then finally, as you may expect, the National Trust use the historic map archive to understand all of their locations across the UK, and to see where either there's changes happening, and just to understand the sites that they manage now and how they previously have been. So they had it into their data archive for that, and we provide the map service to every office and site within National Trust across their whole estate. So everybody in any National Trust location has access to that the web viewer service with the time slider and everything else to understand the location of where they're working. And then just touching on the experience we have from things like the building this map service, we also have a product, points of interest, which we are building. It's much more recent, obviously, than historic maps, but we are building a historic archive from that, from the same principle of being able to understand change, and to see what has been somewhere. So you can look at, so points of interest, if you were to think of it like the information in your sat nav, or if you type stuff into Google Maps. This is the data from multiple suppliers that represents what you see there. And we work with a lot of organizations who use this for information about a location, examples being, and I'm trying to think of the right word now, the Arts Council used it to understand the impact over time when they funded new arts venues or to bring funding into existing venues, to see the impact that has on the local economy by the change in the commercial organisations that appear around that site. In the same way, it's used by the House of Commons Library to understand what's happening in constituents areas in terms of commercial records as well. And We have also been using time series data around flood mapping. So we have a number of products around flooding, as you can understand, going back to what we said earlier about Landmark's focus in the property sector and property transactions, and especially with environmental consultancy and risk management. With that, we're using, in this example, you can see the flood data we've built into this proof of concept. Flood prediction modeling, along with terrain modeling and the 3D buildings data from the Ordnance Survey to see the impact of flood on buildings. And I think that was all of our slides. We're a bit ahead of time, but if anyone has any questions at all in the chat or they want to ask, we've left a bit of space for that as well.